Okay, what's up? I'm not gonna lie, this particular assignment can be a nightmare if you don't know like how to set things up and things like that. You're graphing functions that include radicals, so what you're gonna do is make kind of an XY table is how I would do it. That's just me. And since x, the independent variables inside of a radical, it's going to be, you're going to use this list for all of them. What you're going to do is only pick numbers that are perfect square roots, okay? So I know it's not on this thing, but we're going to put up here that the square root of 0 equals 0, okay? So we're going to start with 0, and then we're going to put 1, 4, 9, okay? You could go to 16, but just stop from there, okay? Make continuation dots because you could keep going. But let's just get 0, 1, 4, 9 graph. So if I would put a 0 where x is, y would equal the square root of 0. Well, the square root of 0 is 0, so we put that, okay? Now if I would put 1 in for x, instead of x I had 1, the square root of 1 would be equal to 1. And if I would put the square root of 4, okay, the square root of 4 in for x, the square root of 4 would equal 2, and then 9, the square root of 9 would equal 3. So that's easy enough, so, and that would keep going forever as well. But this 0, 0 point right here in the middle, you're going to make that, that's where 0, 0 is at for x, y. And for today, because it's going to set you up for something you're doing tomorrow, that only that point, that beginning of the table point, label that 0, 0. Okay, just label that 0, 0. And then 1, 1, so I go forward 1, up 1, and I connect it. 4, 2, forward 1, 2, 3, 4, 1, 2. You don't have to label these. I don't care about those. I need the first point label because that sets us up for something we're doing tomorrow. And then 9, 3. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. Now because we can continue the table, we just make an arrow off that side. Now you don't make an arrow on the other side because anything to that way of 0 would be negatives, and you can't do square roots of negative numbers, okay? So only the arrow comes off this way. The point where the arrow doesn't come off of, we're going to label that because that's for something tomorrow. Now what you're going to do is tear off this sheet because you're going to use it to do the other problems. This right here, this function is known as your parent function of radicals, okay? Just label it. Parent function of radicals, okay? It's like your starting function, parent function of radicals. So every one of these things, and by the way, here's what I'm talking about when I say we'll need this for tomorrow. The directions say graph each function, identify the domain and range. Don't worry about the domain and range, okay? We'll do that in the next video, probably tomorrow, okay? So you're going to want to just make your graphs today. Now the first thing you're going to do when you see that y is equal to x and x is inside of a radical, just ignore everything with it and just set up this parent function here, okay? We'll worry about the other numbers as they come in. So just like before, we want to go 0, 1, 4, 9, and then the results, as we saw here, are 0, 1, 2, 3. Those are the outputs that go with those. Now, here's what you do then. What you do, that's your parent function, but what you're going to do is what's called adjusting the parent function, transforming the parent function, shifting the parent function. It has about 16 names. You're going to put a parentheses where your radical begins and ends, so there's no number inside that, okay? Now outside, I have a plus 1, okay? If it's outside of the radical, that means we adjust the y's, okay? Inside the radical is an adjustment to the x's. It's a shift to the x's. Outside is an adjustment to the y's. So we just have this plus 1 outside, okay? So that means all of the y's I plus 1 to. All these y values, I just add a 1 to that. Y is equal to radical over x plus 1. So I just take the 0, 1, 2, and the 3 and add 1. So 0 plus 1 would be 1. 1 plus 1 would be 2. And 2 plus 1 would be 3. And 3 plus 1 would be 4. Okay? So now I graph these points. Remember, if it's outside of the radical, we make the adjustment to the y. Okay? We add 1. So now you graph 0, 1. Okay? So 0, 1, that would just be up 1, okay? And label that point, 0, 1, 0, 1. That's the only point I need labeled. Okay, 1, 2. So I go 1, 1, 2. Connect, okay? 4, 3. 1, 2, 3, 4, 1, 2, 3. Okay, 9, 4, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, okay? And then an arrow can keep going that way, but not the other way, okay? Remember to label that beginning point, 0, 1. Okay, the next one, y equals the square root of x minus 2. So again, always start with your parent function. So 0, 1, 4, 9. And what goes with them, 0, 1, 2, 3. Okay, now again, parenthesize the inside. There's no number in that parentheses, so anything outside, I make the adjustment to the y. So it says minus 2, so I'm going to minus 2 to all of my y's, okay? So 0 minus 2 would be negative 2. 1 minus 2 would be negative 1. 2 minus 2 would be 0, and 3 minus 2 would be 1, okay? So 0, negative 2, okay? So down 2. Label that point, 0, comma, negative 2. 1, negative 1, so 1, negative 1. 4, 0. 1, 2, 3, 4. And then 9, 1. Okay, now one thing you'll notice from the parent, if you compare the two, this one every point is up 1, hence the plus 1. This one, when I compare these two, okay, every point is down 1 from this one. Okay, it's called a shift. Kind of boring, actually, I'll be the first to admit. Okay, parent function. So again, you want to use the same parent function, 0, 1, 4, 9. That keeps going. And then the outputs are 0, 1, 2, 3. Now, there's an operation inside of the radical. Now, you're like, that's done to the x's. That's an adjustment you make to the x when it's inside of the radical. Okay? If the operation's outside, you do it to the y, but inside, you do it to the x. But here's another kicker, and this is kind of confusing, okay? You have to do the opposite of the operation when it's inside of the radical. So I put inside, do opposite, and you do it to the x, okay? If it's outside, you do the operation it says, but inside, do opposite to the x. So instead of minus 3, we're going to plus 3 to all the x's, and then the y's we just leave because there's no operations outside the radical. So that's 3. 1 plus 3 is 4. 4 plus 3 is 7. 9 plus 3 is 12. Now here's why we did the opposite. Because what's 3 minus 3? That's 0. It gives you what the parent was. 4 minus 3 is 1. Gives you what the parent was. 7 minus 3 is 4, which matches the parent. 12 minus 3 is 9, matches a parent. So if it's inside the radical, you do the opposite. Okay, now to graph it, We kind of need this to go all the way to 12, okay? So, actually, never mind that. Forget that. Just go by 1. So, 3, 0. Okay, now remember to label that, okay? 4, 1. 1, 2, 3, 4. 7, 2. 1, 2, 3, 4, 5, 6, 7, 1, 2. And 12, 3 would be off the graph, so I'm not gonna worry about that, okay? I'm just gonna go like this, and now we're good, okay? So if I compare that to the parent, this time it moved forward from the parent function. Okay, now, parent function, and then 0, 1, 2, 3. Now, look at the operation, it's inside the radical, so again, we do that to the x, okay? So again, inside, do opposite, you do the opposite operation to all of your x's, okay? So the opposite of plus 6, minus 6. So I need a minus 6 from every x I have. So 0 minus 6 would be negative 6. 1 minus 6 would be negative 7. 4 minus 6 would be negative 2. And 9 minus 6 would be 3. Okay? So that's what I'm graphing. So negative 6, 0. 1, 2, 3, 4, 5, 6. Remember, always label that beginning point. That's for tomorrow. Negative 7, 1. Wait a second, did I do that right? No, I'm an idiot. 1 minus 6 is negative 5, okay? Well, I did that wrong, okay? So 1, 2, 3, 4, 5, up 1. Negative 2, 2, left 2, 1, 2, and then 3, 3, okay? So 1, 2, 3, 1, 2, 3. Okay, so it just goes on forever right there. Okay, next problem. Okay, set up your parent function 0, 0, 1, 1, 4, 2, 9, 3. Now look inside the radical, okay? You have to do that to the x, it's got to be the opposite, okay? So inside, do it to the x, and it has to be the opposite, okay? So the opposite of plus 2 is minus 2. So all these x's I minus 2. Negative 2, negative 1, 2, and 7. Now, but there's another operation outside now. Outside, you do it to the y, okay? And it's not the opposite, okay? It is not the opposite. So if it says minus 3, we do that exact operation. So 0 minus 3 is negative 3. 1 minus 3, negative 2. 2 minus 3, negative 1. 3 minus 3 is 0. So now this is what I'm graphing, okay? So negative 2, negative 3. I go backwards 2, down 3. And label that negative 2, negative 3. Okay, negative 1, negative 2. So left 1, down 2. Connect. 2, negative 1. Connect. 7, 0. Connect, okay? So, that's how that works. Okay, next one, x, y. First we'll always start with your parent function. 0, 0. 4, 2, 9, 3. So inside, that's done to the x, but it's the opposite. And I'm going to write that every time. Inside is done to the x, and it's the opposite. So plus 4 is minus 4. So it's negative 4. 0 minus 4 is negative 4. 1 minus 4 would be negative 3. 4 minus 4 would be 0. 9 minus 4 would be 5. Now there's another operation. There's the plus 3. Outside is done to the y, and that's not the opposite. So if we see plus 3, we're going to add 3. So that's 3, 4, 5, and 6. So negative 4 and 3. So I go backwards, 2, 3, 4, 1, 2, 3. Okay, so label that point negative 4, comma 3. Again, I'll need you labeling that first point. Negative 3, 4. 1, 2, 3, 1, 2, 3, 4. 0, 5. 1, 2, 3, 4, 5. And then 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, and there we have it. Okay, next up. This one's a little bit different. These next couple are. So inside the radical, so first get your parent function. Sorry, I'm jumping the gun. That can keep going, okay? Okay, so inside the radical, you don't have anything, so the x is good to go. Leave the x alone. Now, outside the radical, you have two operations. Remember, outside is done to y, okay, and it's not the opposite. Well, you see the plus 2, but we got another operation, which is times 3. You're like, well, I know I have to do them both to the y's, but in what order? Well, times always comes before plus, so we'll do the times 3 first, and then plus 2. Okay, so I'll take 0 times 3 and then just plus 2. That's going to be 2. So that becomes 2. Then I will go 1 times 3 is 3, plus 2 is going to be 5. Now that 2 times 3 would be 6, and plus 2 would be 8. Then 3 times 3 would be 9, plus 2 would be 11. Okay, so I'm good to go. So 0, 2 is the opening point. So 0, comma 2. Then the graph widens. 1, 5. 1, 2, 3, 4, 5. Yeah, it gets a lot steeper because we had to multiply everything by 3. 4, 8. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. And then 9, 11. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I get off the graph, so I'm just going to go with it from there. Okay? Okay, and then my last problem. Set up your parent function, 0, 1, 4, 9. You always set that up first, okay? And the outputs give you, again, let me remind you why that's a parent function, because if you just have the square root of x and not all these numbers, square root of 0 is 0, square root of 1 is 1, 2 is 4 is 2, 9 is 3. Okay, now let's look inside the radical. Again, there is an operation inside, so inside is done to the x, and we do the opposite. So I got to do the opposite of plus 3, which should be minus 3. So every one of these numbers, I minus 3. 0 minus 3 is negative 3. 1 minus 3 is going to be negative 2. 4 minus 3 is going to be 1. And 9 minus 3 is going to be 6. Well, that takes care of the inside. What about the outside? I have two operations. We got a times negative 5 and a minus 1. So we times by negative 5, then we have to minus 1. Okay? So I take 0 times negative 5, and then minus 1, I got negative 1. Okay, now I take 1 times negative 5, negative 6. If you need to use a calculator, go for it. Okay? Then I take that 2 times negative 5 minus 1, I get negative 11. Then I take 3 times negative 5 minus 1 is negative 16. Okay, now I'm ready to roll, okay? So negative 3, negative 1, so I go backwards 3 and down 1. So negative 3, negative 1. Negative 2, negative 6, so I go backwards 2, down 1, 2, 3, 4, 5, 6, okay? 1, negative 11, so I go 1, 2, 3, 4, 5, 6, 7, 8. I ran off the graph, so guess what? I'm just going to make the line continuous and go from there, okay? All right, so obviously on that you have 4 to do. Remember, outside is done to y, inside's done to x, but the opposite. Outside's done to y, times first, minus second. Here you got to do plus 4 to x, and then the y you'll have to times by your parent by negative 4 and add 3.